So here's your quick little video on valence electrons. So it turns out that valence has the same root word as valence, which is like the little topper that you might see on a window. So not a full curtain, but just the one that goes across the top. And this root word means on the edge. So valence electrons are only the electrons that are on the outermost edge of the atom. And so it's defined as the electrons in the outermost layer of electrons. So this particular atom right here, this Bohr model of this atom, has actually 19 electrons. However, it only has one valence electron. So if I asked you how many valence electrons does this atom have, you would say one. But this is easy to see because it's in a picture of an atom itself. So you can see that there's only one electron on that outer layer. However, for the representative elements, now, the representative elements, those are the well-behaved elements. So it means we're not talking about the transition metals or the intertransition metals, but all the other atoms. For the representative elements, determining how many valence electrons an atom has is really easy. The column that the element is in tells you, the number of that column tells you how many valence electrons it has. So this is column 1, and everything in that column has one valence electron. This is column 2, and everything in this column has 2 valence electrons. So it means all of these atoms have 2 electrons in that outermost layer. Now when you get over here, most periodic tables will label these columns as column 13, 14, 15, 16, 17, and 18. The periodic table I gave you in class labels it that way as well, but then it also will say 3A, 4A, 5A. So if it happens to be the one, if you are looking at a periodic table and it only has the 13 through 18 labeled, you just have to remember that to subtract 10. So if this is column 13, it has 3 valence electrons, and column 14 has 4 valence electrons, and so on and so forth. Otherwise, if you have a periodic table that labels the A, so this is 3A and 4A, then the number next to the A is the number of valence electrons. Now hopefully you can see that there is one really standout exception to this rule, and it's helium. And even though helium is in column 18 or 8A, it only has 2 valence electrons, and here's why. Helium only has 2 electrons total. If you were to determine the protons, electrons, and neutrons for helium, you would find that it has 2 protons, and if it's neutral, that means it also has 2 electrons. So how can it possibly have 8 electrons in the outermost layer if it only has 2 electrons total? So you just have to remember the one exception here for helium. Helium only has 2 valence electrons. That's all there is to it.